everybody. Hope you're ready to flex those brain muscles, because today we're going to find the x and y intercepts of some linear equations. So a linear equation is just a line, and it usually is seen in one of these two forms, either standard form or slope-intercept form. So standard form looks like this, and a, b, and c are integers. Slope-intercept form looks like this, m and b are real numbers, and in this case, m is the slope and b is the y-intercept. That's why it's called slope-intercept form. So before we get into some examples, let's go ahead and kind of think about what is an x-intercept, how do we find it, what is a y-intercept, how do we find it. So I drew a little Cartesian plane here, and this is the coordinate system that we use to graph these equations, where we have our x-axis, our y-axis, and this is the origin at 0, 0. So let's suppose I just draw some line. I'll just draw a line like this. It's not going to be perfect. So where is the x-intercept with this line? And when I think of x-intercept, I think of intersecting, right? Because intercept kind of sounds like intersect. Intersecting the x-axis. That's how I remember it. So the x-intercept is where this line intersects the x-axis, which is actually here. So now, how does this help us? We don't want to graph an equation every time to have to find out what the x-intercept is. But we can notice a pattern. What's true about this point? This point is on the x-axis. And what's true about any point that's on the x-axis? Any of these points that are on the x-axis, think about our y. Y is 0, right? We can write this point where x is 4. That's 4, 0. Y is 0. What about this point where x is 2? That's 2, 0. And that's true for any point on the x-axis. So how do we find the x-intercept of this line? We set y equal to 0. Basically, we plug in 0 for y. Set y equal to 0, plug in 0 for y. So now what do you think we're going to do with the y-intercept? This is where this line intersects the y-axis. The same thing is true. Well, a similar thing, right? What is true about all the points on this y-axis is that x is equal to 0. Think about this point down here at y equals -4. That's 0, -4. What about some point way up here where y equals 8? That's 0, 8. All these points on the y-axis, x equals 0. So what if we plug in 0 for x into this line? We'll find out this y value for this coordinate. So that's what we do here, is we set x equal to 0. In other words, we plug in 0 for x. So for an x-intercept, you plug in 0 for y. For y-intercept, you plug in 0 for x. And these answers are usually written as, remember how we said slope-intercept form, the b is the y-intercept? So we'll write y-intercept at y equals 4 or something like that. This is just an example. If the y-intercept is 4, you can write it like this. But there are actually two ways to write this, and it's good to note this because one of the reasons we find these intercepts is so we can graph them. If we have 2 points, we can just draw a line between them. That's how we can graph a linear equation, by just finding both intercepts and connecting a line between them. So it's good to know that this can be represented as a point on our plane as well. Y equals 4. We plugged in 0 for x to find this. So we know that this point is what? X is 0. We plugged that in. Y is 4. So that's the point of the y-intercept on the Cartesian plane. This is the y-intercept itself. Depending on what teacher you have and their instructions, depends on how they want you to leave the answer. But for this video, we're going to write both of these out. If you want to pause the video and try this on your own, you can, and then press play if you want to check your answer. But this is our first example. We're going to find the x and y-intercepts of this linear equation. So this is, as we can see, in slope-intercept form. So this is a little bit beneficial for us. And why is it beneficial? Well, the y-intercept jumps out at us. Remember, the y-intercept is b. And if you don't realize why the y-intercept is b, think about this. For the y-intercept, we set x equal to 0. What happens when we plug in 0 for x here? This just disappears. 3 times 0 is 0, and we're left with y equals 7. So that's why b is always the y-intercept. So for the y-intercept here, I can write y-intercept, y equals 7. That's the y-intercept. And what if I want to express this as a point on the coordinate plane? Well, remember we said that for y-intercept we set x equal to 0. X is always 0 for a y-intercept. And what is y? Well, that's what we solved for. It's y equals 7. So we're going to do the same thing, but this time with the x-intercept. And the x-intercept doesn't jump out at you in slope-intercept form, unfortunately. You have to do a little algebra. So for the x-intercept, I'm going to set y equal to 0. So I have 0 equals 3x plus 7. So now I just got to do some algebra and solve for x. Basically, I need to get x equals something. So I'm going to subtract 7 from both sides. And now I have 3x equals, that plus 7 and minus 7 cancel. 3x equals negative 7. Now I'm going to divide both sides by 3 to get the x by itself. X is being multiplied by 3, so I need to reverse or cancel that process by dividing by 3. Okay, x equals negative 7 over 3. This is actually our x-intercept. X equals negative 7 over 3. And where is this on the Cartesian plane? Well, remember I plugged in 0 for y. So my y is 0. And this is always true for x-intercepts. Y is equal to 0. And my x, well, that's just what I solved for. Negative 7 over 3. All right, now we have a linear equation that's in standard form. So let's find the x and the y-intercepts. So it's the exact same process. I'm going to start with the x-intercept. I'm going to set y equal to 0. So I basically plug in 0 for y. This is what I get. 4x plus 7 times 0 equals negative 14. And you're going to see what happens. This is 4x plus 0. So that just goes away, right? So this can be rewritten as 4x equals negative 14. Now I just need to solve for x, and that's my x-intercept. So I need to divide both sides by 4 to get x by itself. What am I left with? X equals negative 14 over 4, which can actually be simplified as negative 7 over 2. And if you want to punch this in your calculator and write it as negative 3.5, that's acceptable as well. But I'm just going to leave it. I always just leave stuff as a fraction. So this is my x-intercept. X equals, where's x-intercept? X equals negative 7 over 2. So what is the point? Remember, I plugged in y for 0. My y is 0. My x is negative 7 over 2. Bam. All right, let's find the y-intercept. So now I plug in 0 for x. So let me erase a little bit. I'm going to have to make a little room. Sorry about this. Didn't plan ahead quite well enough. Okay, so now I'm going to plug in 0 for x. Set x equal to 0. So 4 times 0 plus 7y equals negative 14. 4 times 0 is 0. 7y plus 0 is just 7y, right? All right, so 7y equals negative 14, so I'm going to divide both sides by 7. And I get, let's see, these 7's cancel. I get y equals, ooh, this will actually simplify nicely. Negative 14 over 7, that's negative 2, right? Y equals negative 2, so that's my y-intercept, is y equals negative 2. And what is this on the Cartesian plane? Let's see, we plugged in 0 for x, so the x is 0, and we got negative 2 for the y. All right, now we have another example, this time again in slope-intercept form. So I can just go straight into the y-intercept, right? The y-intercept is this b, so the y-intercept is y equals 1/2. And this can be expressed as what? Remember, to find the y-intercept, x is always 0 for the y-intercept. So that's the point on the Cartesian plane. So now all we have left is x-intercept. And for that, we just need to substitute in, let's see, x-intercept, y, 0 for y. So I'm going to plug 0 in for y. 0 equals negative 2x plus 1/2. I'm going to subtract 1/2 from both sides. This leaves me with what? These cancel. I'm left with negative 2x equals negative 1/2. Negative 2x equals negative 1/2. Now I have one more step, which is divide both sides by negative 2. Divide both sides by negative 2. And this is a little tricky because I'm dividing a fraction by a whole number. But what negative 2 is that's just negative 2 over 1. And how do I divide two fractions? I flip this bottom one and I multiply across. That's negative 1/2. So now I multiply negative 1/2 times negative 1/2. These negative 2's cancel, so I'm left with x equals negative 1/2 times negative 1/2. That is simply positive because it's two negatives. 1/4. I just multiply across. So this is our x-intercept, is at x equals 1/4. And if we represent it as a point, it is what? 1/4, comma, 0. The y is always 0 for x-intercept. All right, last example. This may be getting a little repetitive for you, but if you're getting good at it, that's good, because that means graphing linear equations is going to be really easy for you, because this is usually the process, or one of the methods, one of the processes we can use to graph linear equations. So it's good to be good at this. So I'm going to find the x-intercept. So I'm going to plug in 0 for y. What does that give me? Negative 6x plus 4 times 0 equals negative 12. So this 4 times 0 just goes away because that's negative 6x plus 0, which is just negative 6x. And this equals negative 12. Now I divide both sides by negative 6. Ooh, we got a nice number. So a negative divided by a negative is a positive, and 12/6 is just 2. So I have x equals 2. X equals 2, and that's my x-intercept. And as a point, this can be expressed. My x is 2, and my y is 0. Okay, what about for y-intercept? Now I'm plugging in 0 this time to x. So I have, let's see if I have room down here. I have negative 6 times 0 plus 4y equals negative 12. So this negative 6 times 0 is gone. So I have 4y equals negative 12. I'll rewrite it. 4y equals negative 12. Now all I have to do is get y by itself. I'm solving for y. So I got to divide both sides by 4 to get rid of that 4 in front of the y. So those 4's cancel. I'm left with y equals negative 12/4. Can I simplify this? Let's see. 4 goes into 12 3 times. So this is actually y equals negative 3. I'm going to write that over here. Y equals negative 3. And as a point, remember we plugged in 0 for x, and we got negative 3 for y. So 0, negative 3. Hopefully this video helped. The next video will be on graphing these equations. Make sure to hit like and subscribe if it did help. If you have questions, feel free to leave those below. And until next time, keep flexing those brain muscles. Keep making those brain gains.